as quickly as we can. So let me read it and then we'll get into it. Number 18 on page 418 reads, the graph above, my graph is at right, shows the function g, where g of x equals k times x plus 3 times x minus 3 for some constant k. If g of a minus 1.2 equals 0 and a is greater than 0, what is the value of a? All right, who, what, when, where, how? Starting with the what question, what kind of problem is this? And it's a geometry problem. It's a coordinate geometry problem. The when question has to do with our time. This is number 18. So chances are, even if we get to this problem, we might not have a whole lot of time to solve it at this point. And then the where question, well, this is the last problem in the section, therefore this is going to be a hard problem. And then the how question, how are we going to do this thing? Okay, no answer choices to work with, so that limits us a little bit. Now this is a toughie because it kind of combines some algebra concepts possibly. We have a function here, and then it combines some coordinate geometry. So most likely from looking at this thing, we're going to have to use not only the graph, but also the function in order to solve this problem. So that's sort of the how, that's our method that we're going to use. And then the who question asks, are you going to attempt this problem and are you not? And this really has to do with how much time you have. If you're running short on time, you might want to skip this problem and go back to something you skipped earlier that might not take as long. That's really your choice and something you have to think about as you're going through these problems. All right, so let's talk about how we are going to set this up. And I'm going to get a nice colorful pen here, not black since we already used black. So we're going to talk about how we can set this guy up. So we're given the function and we're given the graph. This graph represents g of x. So this is the functional representation of the graph. This is the graphical representation. And we have this unknown constant k in our function. And then we're going to solve for some other constant, which is going to be a in this case. So we have some unknowns going on here. Yes, and we don't necessarily like unknowns, so let's try to convert these unknowns into knowns. That's our goal. And really what we want to do here is use the graph as much as possible because we like graphs, they're visual. And we really like this one because we can assume it's drawn to scale. Why? Because we're not told that it's not, and we love things that are drawn to scale. So this is great. We can assume this guy is drawn to scale. So not only can I label the vertex point here, the vertex is going to be the point 0, the x value is 0, the y value is 1, 2, 3, 4, negative 4. I can also label the x-intercepts. So there's an intercept at 3, 0 and an intercept at negative 3, 0. All right, now why do I want to do this? That's a really good question. Now the reason I labeled the intercepts is so that hopefully you could see something here. Notice if we have points on the graph, we can always plug in these known points for our x and y values in the function, or our x and functional values, our g of x values in the function, to solve for an unknown, in this case, k. So I could solve for k if I wanted to, and the way to solve for k is probably using this point here. But I might not even have to solve for k, because notice what we're trying to find is this value a. Gosh, I didn't even mark it right. A was supposed to be greater than 0, not 0. If it was 0, we'd be done, right? So I'm sorry about that. Hopefully you didn't notice that. Hopefully you were reading your book and not looking at my bad representation here where I put in a bunch of wrong stuff. Okay, but notice we're solving for a functional value where the functional value is 0. We're actually finding the x value. We're relating the x value to a functional value of 0. So we want to ask ourselves, where is this function equal to 0? Where on the graph is g of x equal to 0? And on the graph, g of x, or the y values, are equal to 0 at the two x-intercepts, right? So we know that g of x equals 0 when, this is important, when x is either 3 or when x is negative 3, right? Because where the function is 0, that just represents our x-intercepts, and we're able to find our x-intercepts based on the fact that this diagram is drawn to scale. All right, so knowing that, remember that we want to solve for a now, and a represents some part of the x value. So what I want to do here is I'm going to write our two x values that yield a functional value of 0. So 3, when x is 3, the function is 0. And when x is negative 3, the function is 0. And now I'm just going to use some substitution here. And what I want to solve for is when a minus 1.2, when the functional value at a minus 1.2 is 0, I can just use substitution like this and solve for a, right? Since what is here represents the x value of these x-intercepts, then I can just set that x value equal to the intercept value and solve for a. And I need to do it for both cases. So a minus 1.2 equals 3 and a minus 1.2 equals negative 3. So I'm going to solve for this first one. I can add 1.2 to both sides, plus 1.2. And what I end up getting is a equals, these are going to cancel out, and I get 3 plus 1.2 is 4.2. So that's one value for a. And then if I add 1.2 to both sides of this equation, I get a equals 1.2 cancels out on this left side, and then I get negative 3 plus 1.2 happens to be negative 1.8, I believe. And now we get two values for a. So, how do we grid in two different values for a? Well, we're told that a is greater than 0, and I did mark that wrong initially, but now we know a has to be greater than 0. So if a has to be greater than 0, we're going to disregard this case where a is negative, and a is just 4.2. Now notice I could have solved this in a different way. I could have actually found what k was equal to by plugging in, say, the y-intercept or the vertex of this point, but I didn't need to. So we kind of did this probably in the quickest way and easiest way possible, but there's other ways we could have solved this guy.